All right, just as I said, I want to compare rates and ratios because they are so similar but have a couple of very important differences. So we're going to continue our discussion about ratios, and then we're going to relate it back to rates. Okay, so 6-2 rates, the big thing was that the units are different. Okay, when we're talking about a ratio, we are making a comparison, but we're making a comparison with units that are the same. Okay, so maybe I would say I want to compare the number of days that it takes me to read a book compared to the number of days it takes me to watch a movie. Okay, I'm comparing two of these same things. Okay, so the big idea with ratios is I'm still making that comparison days per days, but the units are the same. Okay, so that's one of the main differences between rates and ratios. The units are the same. So let's look at example 2. It takes Mr. Garcia 3/4 of an hour to go to work, and it takes Miss Wong 10 minutes to go to work. Find a ratio comparing Miss Wong's time to Mr. Garcia's time. Okay, right now you're saying, well, if you're asking me to find the ratio, one is in hours and one is in minutes. But I can make them both into the same unit so that I can compare them inside a ratio. Right now, I see it probably being easier to convert both to minutes, but it really doesn't matter which way you go, okay? And this was asking Miss Wong to Mr. Garcia. So, okay, so again, they gave me the direction. Miss Wong was 10 minutes. And Mr. Garcia was 3/4 of an hour, which we know is 45 minutes. Okay, let's divide that down so it's something we can actually understand. Okay, let's change that into a fraction. I guess we could have reduced by 5. Okay, so the amount of time for the ratio of amounts of time from Miss Wong to Mr. Garcia is 2 to 9. That's the ratio, their comparison, 2 to 9. I did have that decimal up there as well. That's going to be helpful because we can look at that as a percent. So this would say that Miss Wong, her time is 22% compared to Mr. Garcia. Okay, so we could look at the ratio, we could look at it as a fraction, we can look at it as a decimal, but also percent. Okay, that brings up pretty much the really big idea in this section is we can talk about percent discount or increase. Okay, and you're going to see this a lot, so I'm going to star it because I want to make a big deal about it. Okay, to find the percent discount or increase, you're just going to have the ratio of your discount or increase, whichever you're doing, compared to the original price. Okay, we could also look at percent tax. And this would be the ratio of tax compared to the selling price. And we'll do a couple examples of these, okay? But these again are ratios, just like this problem was. This is a ratio of comparison of time, but we can look at it as a percent. These, we're going to look at the ratio, but the percent is more helpful when we're talking about money. So we're going to look at example 3. A pair of jeans originally cost $29.95. They were reduced to $23.95. The tax on the reduced price is $120. What is the percent discount and what is the percent tax? Okay, so let's look at percent discount first. Okay, and it says we need the ratio of the discount or increase. Okay, so I went from $29.95 to $23.95. That's a discount of $6. So I have my amount of discount or increase, okay? And then I need my original price. The original price was $29.95. Okay? Are these two items the same unit? Yeah, they're both money. Okay? So that's a ratio. But I want to figure out what percent is $6 of $29.95. So now we can just divide. Which equals 20%. So that was a 20% discount. Okay? The second part of the question says, what is the percent of tax? Okay, so we can go back up to this percent tax. So we need the amount of tax, which was $1.20. Over the selling price. And we know that the selling price ended up being $23.95. Okay, again, these are both money, so it's a perfectly good ratio. And again, this ratio is going to allow me to find, well, what percent of my price that I'm paying is the tax. So we would do $1.20 divided by $23.95. And it looks like 5%. So there's 5% tax on there. Okay? Now, our last idea in this section talks about how we can use ratios when we're maybe mixing up maybe a spray for your lawn, or maybe you're mixing up a lemonade. And when we need like 1 part of sugar and 3 parts lemonade mixed or something like that, it tells us how to use quantities and make larger quantities out of it. Okay, so let's look at example 4. Instructions for preparing a lemonade drink call for 3 parts of water for each part of lemonade concentrate. How much of ingredient is needed if we want to make 10 gallons of lemonade? Okay, so in other words, I know that I want 10 gallons of lemonade, but all I know is how many parts water to how many parts lemonade. Okay? I don't know what that part is. Is it a cup? Is it 2 ounces? I don't know that. Okay? So if you don't know, you can go ahead and put a variable in there, and that's what we'll solve for. Okay? So I know that for every three parts of water, I'm also going to add 1 part lemonade, and I want that to equal 10 gallons. Okay, but I just said I don't know what that cups or ounces or that part that makes them equal, that unit that's making them equal, I don't know what that is. So I'm going to put a variable in here. So 3 parts of some quantity plus 1 part of some quantity is going to give me 10 gallons. So I have 4x equals 10, x equals 2.5. Okay, 2.5 what? Well, this was in gallons, remember? And I have to keep my units all the same. Okay, I have to keep my units all the same. So I have 2.5 is x. So if I put this back in here, 3 times 2.5 is telling me I need 7.5 gallons of water. And 1 times the 2.5, 2.5 gallons of the lemonade. If you add those up, do you get 10 gallons? Okay, this is a really helpful tool when it gives you a ratio but doesn't give you that increase increment. Okay, so that's when you kind of use this idea. All right.